traditional topics in mathematics: area, perimeter, and volume. So, at the beginning of each math test section, the set will provide you a formula sheet that covered much of what you need for problems related to area, perimeter, and volume, which means that you don't need to remember the formula. You don't need to remember the formula. So set is gonna provide you the formula. Okay, so they're just telling everything here. They're just telling everything here. Just read this part. They're just gonna provide you all the stuff, all the formula that are necessary. So okay. I'm gonna start with some basic geometry shapes, geometrical shapes. For an example, uh, a circle, just like this, a circle, and um, a rectangle, a circle, a rectangle, and area of triangle. Pythagoras. Okay, so basically, they're just trying to deal with different type of geometrical shapes. For an example, circle, rectangle, triangle, and they're also going to talk about box, cylinder, sphere, cone, volume of a pyramid. So this is basically a pyramid. Okay, so uh, are you comfortable with this kind of geometrical shapes or geometrical structures? Do you know what
Yeah, I
these
know
things
them.
are? Okay, um, so I'm just gonna talk about again because this is circle. So the radius of a circle is r, and the area of a circle is pi r square. Pi is just a constant. Pi is just a constant, and the circumference of the area of a circle, which means basically this thing, which is basically this thing, the circumference. This is called the circumference. Okay, the circumference is just like what happened with my pen. Sorry, I really don't know. Okay, the circumference is this thing. The It is also kind of perimeter. A circumference is a kind of perimeter, and radius is uh, this distance. This we represent this with r, and area of a circle is this whole thing. This whole thing. This is the area. Okay. Okay. So the rectangle has an area with length with multiplied by each other. This is the length. This is the length, and this is the width. And this is the triangle, and the triangle has an area with half into half multiplied by the base. This is basically the base. You can take the base whatever you want. It not necessarily be this thing, okay? It not necessarily be this particular side. For an example, if a rectangle looks like this, if a rectangle looks like this, then you can just take the base as this side, okay? You can take the base as this side,
Okay.
and then you just need to consider the height as this side. So whatever you are gonna take as the base and whatever you are just gonna take the height always need to be perpendicular. The height always need to be perpendicular. The height always need to be perpendicular with the base. So for an example, if I'm gonna take the base as to be this side, the perpendicular side, the perpendicular distance of the another side, like this. So this would be the base, this would be the base, and this would be the height. Okay,
Mhm.
you just need to be sure about what is the perpendicular side, perpendicular distance, and what is the another side. So don't be confused about that. Okay.
Okay. Yeah.
So this is the area of a triangle, half into base into height, half multiplied by base multiplied by height. We have a particular theorem which is called the Pythagorean theorem. A Pythagorean theorem basically tells you Pythagorean theorem basically tells you that relationship, the relationship of length for any particular uh, triangle. What does that mean basically? What does that mean? It means that consider a triangle like this. Consider a triangle like this. These all of my triangle are looking like a right triangle. So this is a triangle. Consider the length of this side. The length of this side is A. The length of this side is B, and the length of this side is equals to C. So I'm interested to know about the relationship. I'm interested to know about the relationship of these three sides of this triangle. So there was a great mathematician in Greece, maybe in Greece. There was a great mathematician. His name was Pythagoras, and he gave this theorem. He said that for this triangle, please don't misinterpret with another triangle uh, because I have just gave the different side names for this triangle because the side names for this triangle and this triangle is not the same. So for this triangle, you can write b squared is equals to a squared plus c squared. Okay, the you can just make a relationship like this. You can make the relationship like this. We will talk about that later, but primarily I'm just giving you some basic idea. Do you have any problem with this thing?
No, yeah, I understand.
Okay, but I'm just talking a little bit slower because I think mm, I'm trying to be I'm just trying to be a little bit. I don't want to rush basically because
Yeah,
I think maybe you just more time on geometry and trigonometry, so that's why I'm just thinking I shouldn't rush because these are some very basic, but I'm not gonna skip those things. Okay,
yeah.
if you really want to skip these things, then please tell me that. Please skip. I understand this thing, and then I will skip. Otherwise, I won't skip. Okay,
Okay.
so this is a box. You can say this is a box actually. A parallelogram, but actually it is a solid object. A solid object. This is basically a these are all are two-dimensional objects. 2D objects. These all are two-dimensional objects, but all of these are three-dimensional objects. Three-dimensional objects. All of them. So what actually these things mean, that is, uh, these these objects have height. These objects have height. Height is a dimension. These objects have width, and these objects have length. You got it, right?
Yeah,
So all of these objects have the height, the width, and the length. All of them have the same. So, uh, for an example, this is a box and this is a cylinder. You can also consider this cylinder has a height, a width, and a length. And we will discuss about that later. How a cylinder can possess a width, or how a cylinder can possess height. So for this cylinder, we need to find out the volume. For this sphere, we need to find out the volume. This is 4 by 3 pi r cube. R is the radius. And for the volume, for the volume of a cylinder, we have pi r square. H is basically the height. The distance. This is the h. And for a cone, we have the volume 1 by 3 pi r square h. We have a pyramid. We have a pyramid, and the for the pyramid we have 1 by 3 length multiplied by width multiplied by height. You will understand these things later. Basically, we have so many maths, so
yeah.
I'm just giving you the preliminary ideas. So key facts: a circle has 360 degrees. There are 2 pi radians in a circle. There are 180 degrees in a triangle. So it means that a circle has 360 degrees. So for an example, this is the circle and this is the radius. So if you start walking from here and you just walking here, and then you are again coming to this point.
Yeah.
Then the angle you covered, that is basically 360 degree. Okay, 360 degree. You can basically
Yeah.
there are two types of angle. There are two types of units for an angle. The angle units have two different distinct units. That is, one is the degree. One is the degree. I'm sorry for my bad handwriting, and the another is the radian. The another is the radian. You got it right.
Yeah.
So you can just make a relationship with the degree and the radian. You can make some relationship. You can make some relationship with the degree and the radian because it's very important. I don't know whether they are interested to solve those type of problems to convert degree and radian, but degree can be converted to radian and radian can also be converted to degree. So for the simplest example, and uh, for your kind information, you can write 360 degree is equivalent to 2 pi radian. 2 pi radian. You can just put a small c over the head of this number to denote radian. Some book allows that, and some book don't allows that. They just write a small c to denote the radian. Okay, so
Okay.
these are some very basics. And 180 degrees in a triangle, it means that all of the angles for a triangle, if you just add these angle and these angle, the the sum of angles, the sum of angles would be 180 degree, which is pi degree. Okay, I think these things are helping us. At least the pen. I'm talking about the pen. At least I'm not just using my mouse and pointer, right?
Yeah.
Uh, okay. Um, we know the area of a triangle because we have already covered it here. We've already covered it here. Okay. So in your math class, you have learned this formula as A equals BH by 2. This formula is perfectly fine to use as well. What is the area of the triangle drawn below? Just give me a moment. Till I'm just trying- Just give me a moment. Let's try to paste it. Okay. What is the area of the triangle drawn below? I think that's very simple for you. The area of a triangle is half into base into height. So you just need to do half into base, that is 7, into height is equals to 3, right? This
Mm-hmm.
is the area of the triangle.
Yeah.
So this is the height. Sorry, this is the base. This is the base, and the height is 3. Okay, the height is 3. This is
Yeah.
very important because don't mess up with the height. Don't mess up with the height. Don't consider this side as to be the height, or
Okay.
don't consider this side as to be the height. For example, this is A. The height, the length of this side. Don't consider it as the height. So
Okay.
this is quite simple. And then we have the uh, we have uh, we have a rectangle area. So rectangle area, uh, what is the area of a rectangle with a length 6 units and width 4 units? You know, that is 6 into
Yeah.
4,
Those
that is
times. Yeah.
24. Simple. Okay. So perimeter of polygons. Perimeter of polygons. I'm not understanding why this thing is not just letting me to view one single page. It's the issue here. The issue here. I don't understand. For the perimeter of polygon, what is basically the meaning of a perimeter? The meaning of a perimeter, the meaning of perimeter is just like you just need to find out the summation. You just need to find out the summation for the length of all of the sides for any particular geometrical body. Any
I know
particular
the
geometrical body. Sorry?
I know the
Okay.
perimeter.
Okay. So you can just find out the perimeter for a triangle, for a rectangle, or whatever it is. So the parallelogram area, maybe you also know that. So the parallelogram is the base into height, and a parallelogram is the four-sided figure that has opposite sides that are parallel. A rectangle is a special form of a parallelogram that has only 90-degree angles. The area for a parallelogram is given below, base into height. So for a rectangle, the only difference that is for a rectangle, we just multiply, these two sides to find out the area,
Yeah.
A multiplied by B. But for the parallelogram, we don't multiply. We just need to find out the height. We just need to find out the height. For an example, this is a parallelogram, and this would be the height, and then we just need to also find out the height. Okay? Because we are not gonna multiply for this parallelogram to find out the area. We cannot do A multiplied by B. This is not right. This is wrong. Just be careful.
Okay.
Um, Parallelogram area, trapezoid area. We also this is quite important because a lot of times we really forget about this. What is the area of a trapezoid? Uh, that is for to find out a trapezoid. Trapezoid is just like such kind of four-sided geometrical 2D object, not object 2D 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 figure 2D figure, two-dimensional figure, such kind of geometrical 2D figure. There is no similarities or there is no symmetry. The symmetry is not mandatory. For an example, you can also call a parallelogram as a trapezoid. A parallelogram is just a special type of trapezoid. So to find out the trapezoid, you just need to use this formula, and this formula says that you just need to add these sides, the length of this side and the length of this side, and then you just need to divide it by 2, and then you just need to multiply it by its height. Okay, so this is basically a base. And what is the base basically? The base are the sides which are parallel, which are parallel, which are parallel. You got it, right? This is very
Yeah.
important because you cannot take this side as the base or this side as the base. No, you cannot take that. You cannot take that. The only way to find out the area of the trapezoid, you just need to have at least two sides parallel with each other, and the parallel sides are needed to be taken as the base. So this is a base, this is a base, and this is also a base. And these two, as they are not parallel, so they are not the base. You got it,
Oh,
right?
yeah.
Do you have any problem with this? Do you have any question? Do you have any question?
Not so far, no.
Okay, so what is the area of the trapezoid drawn below? So this is very simple. This is very simple. So we just need to find out the area of the trapezoid. So to find out the area of the trapezoid, we just need to take the parallel sides as the base. We just need to take the parallel sides as the base. So this is gonna be 4. This is gonna be plus 4 plus 6. 4 plus 6 divided by 2 multiplied by the height equals 3. So 10, 5 equals 15, right?
Yeah.
Okay, all right. Okay, all right. So, um, so the surface area. So you just need to calculate the surface area for a right rectangular prism. For a right rectangular prism. So this is basically a box, solid object. So how to do that? How to do that? The surface area for any, you just need to find out the three different surfaces for right rectangular prism in order to calculate the total surface area, for a volume, for a 3D object, basically. It means that okay, give me a moment. You just need to find out the surface area. You just need to find out the surface area for this side. This is basically one side, and then you just need to find out the area for this side. I'm sorry, this surface, this side, and then you just need to find out the area for your simplicity. I'm just writing like this. I'm just using this side, and then you just need to multiply it, right? Do you
Yeah.
got me?
Yeah.
So in order to calculate the total surface area, the total surface area, we have the green area too. We have two different green areas. We have two different pink areas. We have two different yellow areas, right?
Yeah.
So that's why they are just doing like this. So that's why they are just multiplying. That's why they are just uh, this multiplying like this, because they are interested to find out the total amount of area, total amount of surface. To find out the total amount of surface, you need to know the area of this side and then multiply it by 2, because these same surface has the same surface like this, okay?
Okay.
And then you have the same surface like this. And then for this pink, you also have the light pink, right? You got it?
Yeah. Yeah.
Okay. All right. So I think you can solve the problem. What is the surface area? What is the surface area? I'm just focusing on this problem. What is the surface area of a right rectangular prism with a height of 3 units, a length of 5 units, and a width of 4 units? Just so you can just for your simplicity, you can like write like this: 3, 5, and 4. Okay, make a pair with these two, make a pair with these two, make a pair with these two, and then make a pair with these two. 3, 5, 5, 4, and 3, 4.
Yeah.
It means 3 into 5, 3 multiplied by 5, 3 multiplied by 5 multiplied by 4, and 3 multiplied by 4, and then multiplied it by 2, multiplied it by 2, and then multiplied by 2, and then add all the numbers. You got it?
Yeah.
Okay. I'm just telling you for your simplicity. For your
Okay.
simplicity, you just need to make some pairs. Okay, you just need to make some
Yeah.
pairs. So for your practice problem, what is the area? What is the area of a triangle with a height of 3 units and a base of 4 units? I think we can do that. Um, what is the perimeter of a rectangle with a width of x and length of 2x? That is basically x plus 2x into 2, right?
Yeah. Wait,
3x.
which one is
This two, number two problem,
oh,
that is 6x.
okay.
What
Yeah.
is the perimeter of a rectangle with a width of x and length of 2x?
Oh, okay.
Perimeter.
Yeah.
To find out the perimeter, you just need to find out that summation for a pair of sides, and then multiply it by 2,
Yeah.
right? X
Yeah.
plus 2x completely multiplied by 2, that is 6x. Okay, now practice problem number 3. What is the area of the parallelogram below? Can you do it? It's simple. What is the area of this parallelogram?
Parallelogram is based on height, right?
Uh, yeah. The Exactly, the area of the parallelogram would be the base multiplied by the height. Okay,
So
then
that
tell me the answer. Can you please tell me the answer?
is it 12?
Yeah, that would be 12. Exactly. That would be 12. Number 4.
Um, What's the formula of a trapezoid?
Problem number 4. Solve the problem number 4. I'm just asking you to solve this problem 4.
Yeah.
Do it.
What's the formula again for trapezoid?
Okay. If a trapezoid has a height h and an area of 6h square units, what would be the area of a trapezoid with bases of the same length but a height twice that of the original? If a trapezoid has a height h and an area of 6h square units, what will be the area of trapezoid with bases of the same length but a height twice that of the original? You are just asking what is the area for a trapezoid. Are you asking me what is
No,
what
I'm
is
asking like the formula. Like how do you find
sorry, can you please tell it again?
the formula from the
The formula for the trapezoid.
yeah,
Okay, the formula for the area of a trapezoid, the formula
yeah.
for the area of a trapezoid, that is um base 1 plus base
Oh,
2 divided by 2, then multiplied by with its height. That is the area
okay.
of a
Okay.
trapezoid.
Okay.
So, okay, can you please solve it now?
Yeah.
Okay, then try it. Let's try.
Okay.
If a trapezoid has a height 8 and an area of 6h square units, what would be the area for a trapezoid with bases of the same length but a height twice that of the original? So I'm just gonna try to apply my method. I don't know. Maybe that will work. Maybe that will work. So the problem number 4, this is the solution. Basically, this is the solution. So I'm just creating two different trapezoids, but and you just need to find out the base. You just need to find out the base for the first first the very first trapezoid, and then you just need to apply the base. You just need to find out the base from the first trapezoid, and then you just need to plug it in. You just need to plug it in the second trapezoid. What does that mean? What does that mean? It means that it means that it means that consider two different trapezoids and then find out the base from the first trapezoid. They're just trying to use the very shortcut formula, but I just want to try with my method. That is uh, A equals, sorry, okay, A equals B1 plus B2 divided by 2, 8. So you just need to find out the base. You are just considering the B1 equals B2, right? So if you are considering B1 equals B2, then 2B, then A becomes 6H equals 2B by 2. That is basically B, and then H. So B equals 6. B equals 6. And then of a trapezoid with bases of the same length, but a height twice of the original. The area. So area would be A2 equals bases of the same length. B equals 6 plus 6. 6 plus 6 divided by 2. 6 plus 6 divided by 2 into 2 multiplied by h. What is the h? H of the twice. Okay. So to cancel 6 plus 6, 12. That is 12 h. Let's see my answer is correct or not. Yeah, that is correct. So I'm just asking you whether you have understood my solution procedure or not.
Yeah, I understood. So it's
I'm
two
just
different. It's two different equations.
yeah, two different equations because we have two different trapezoids.
Oh, oh,
Two
because you
different
found.
trapezoids. So
Oh,
you can just consider this as to be the trapezoid number one. You can consider
mhm.
as to be the trapezoid number one. We have two different trapezoid, okay?
Yeah.
We have two different trapezoid. And for the trapezoid number one, basically I'm just plugging the area and the height. The area and the area and the height. Yes, the area and the height. The area and the height. The area and the height. For trapezoid number one, I'm considering the area to be as A1, and A1 equals to if a trapezoid has the if a trapezoid has a height h and area of 6h square unit. Just write the equation. A equals B1 plus B2 divided by 2 multiplied by h, right?
Mhm.
So height is declared as h. So you can just write as you can just consider it h1, right? H1 equals h and A1 equals 6h square unit, right? And
Yeah.
the base are the same. So B1 equals B2 equals what? Simple algebraic problems. Simple algebraic problems. Find out the base from the trapezoid number one. And I found out that the base is equals to 6 unit, right?
Yeah.
Base is equals to 6 unit. And then, and then, and then you just need to, sorry, what happened? And then you just need to plug in the value, plug in the value of the base, b equals 6 into the second trapezoid. The question setter is asking you, the area of the second trapezoid because the area of the first trapezoid is already given as 6 8 square units. I'm not asking you, or the question setter is not asking you the area of the first trapezoid. They're asking you about the second trapezoid.
Yeah.
You got it, right?
Yeah.
So if you want to find out the area of the second trapezoid, then you just need to plug in. You just need to plug in the value of the base from the first trapezoid, and that is 6.
Okay.
The area of the second trapezoid equals A2. Consider A2 equals B1 plus B2 divided by 2 mole multiplied by H2, right?
Yeah.
You can use symbols or whatever it is. You can just use simple techniques. If you can find out some different techniques, that's completely okay. Do it. Do it. Try it. I'm just thinking in this way. Maybe you are not gonna think in this way. That's okay. And that's the beauty of mathematics. So then put the value because the bases are the same length. So B1 equals B2 equals 6. That is already given. And put the value, and then you will get the answer like this. Okay? Because they are already telling you that for the second trapezoid, the height is twice. For the second trapezoid, the height is twice. So it means that H2, the height of the second trapezoid equals 2h, right?
Yeah.
H2, H2 denotes the height of the second trapezoid. H2 denotes the height of the second trapezoid. H2,
Yeah.
H2, these are some variables. I'm just declaring some variables and I'm just using some symbols to make our equation look simple because H2, H subscript 2, A subscript 1, these are some advantages of the algebra. You have to take the advantages of algebra. You have to use the subscript. You have to use the superscript. Okay, A1, A2, B1, B2, H1, H2. It's a nice problem. It's an amazing problem. Okay. Have you understood or not?
Yes.
How clear?
95%.
95%. Okay. Okay. The rest of the 5% will be clear if you are gonna solve some extra problems with your own hand, inshallah. So
Okay.
practice number 6, if maybe I just need to use the eraser. Okay. Okay. If the perimeter of a rectangle is 24 inches, what would be the value? What would be the value of the length of the width of the rectangle in order to maximize in order to maximize the rectangle's area. If the perimeter of a rectangle is 24 inches, you can just use some symbols, you can just use some variables, because using the variables or using the symbols will look the equation quite similar. And to plug in the values and using some equations, because I've just, in this problem number 4, I've just created two different equations. This is
Yeah.
the equation number 1 and this is the equation number 2. And that's the beautiful part of any algebraic problem. This is basically an algebraic problem. You can consider it as an algebraic problem, and that's the most beautiful thing. That is, you can just make some equation, and then you can just solve the equation in order to find out the values of the variables. And you can write as like this way: if the perimeter of a rectangle is 24 inches, for an example, P equals 24. You don't need to write the inches. P equals 4. What will be the value of the length and width of the rectangle in order to maximize the rectangle's area? OMG, this is basically a calculus problem. Okay, this is basically a calculus problem. So, but we cannot use the calculus. We cannot use the calculus. We just need to use our simple mathematics. But I think this is one of the base problems. One of the base problems I really solved in calculus. And most importantly, for your kind information, uh, we drink different types of beverage. For an example, Coke. We have can like this, right?
Yeah.
Can. This is Coke. Consider this Coke. There's a math problem which tells you how to optimize the maximum surface area, or the maximum volume, how to optimize the maximum volume or the maximum size area of the surface for such a given volume. For example, the volume is declared, the volume is given, we know the volume, and we're asking what will be the maximum area, how the shape of the body can be. This is the calculus problem. And that's why the cans of the Coke cans, or some canned food, some canned fish, they look like this way, okay? Because that is the most optimized size, optimized surface area, or optimized volume, because they're not interested too many raw materials to produce a particular packet, particular metal sheet. Okay, so that's why they're just designing the structure like this way, because that's the most optimized surface area, or most optimized volume. Whatever our consideration is, we just need to solve the problem like this. But in this case, in this problem number 6, we are not allowed to solve the problem by using calculus. We just need to use the simple mathematics.
I think you can just multiply it. So is it 8 and 3?
You're just telling the answer, right?
Yeah, I think. Is it 8 and 3?
You can just let's see whatever they're doing. You're just telling the answer. Eight and 3.
Yeah.
Okay.
8 times 2 and 8 times 2 is 16, and then 16, and then because 8 times 3 is also 24, so that would make sense. I think.
Okay. But they're telling you, so the length and width should be each 6 inches in order to maximize the area of the rectangle. The perimeter,
Oh, the area?
if the perimeter of a rectangle is 24 inches, what would be the value of the length and the width of the rectangle in order to maximize the rectangle's area? Because they are giving you the perimeter. They are giving you the
okay.
perimeter.
Yeah.
The perimeter equals to 2 multiplied by 8 multiplied by
Oh,
W,
okay.
right?
Yeah.
So you just need to find out the maximum area, and that is why I'm talking about the calculus problem. Okay?
Okay. Yeah, sorry.
You're not allowed to use the calculus. So I just
Yeah.
want to look at their solving the problem, how they have used the procedural method to maximize the area of the rectangle while maximizing the perimeter. The rectangle should be a square. The maximum is the area of the rectangle, while maximum the perimeter. The rectangle should be a square. You can see why this would be by trying out some sample values for length and width that would allow for a perimeter of 24. Length 6 inches and width 6 inches, area is 36 square inches. Length 7 inches, length 7 inches, width 5 inches, area is 35 square inches. Actually, they are trying to plug in some values and they're just trying to find out the area with some trial and error. With some trial and error. Okay. So
Yeah.
with some trial and error, and the perimeter is given. Okay, the perimeter is 24.
Yeah.
So perimeter P equals 24. That is 2 times L times W. So L multiplied by W equals 12, right?
Yeah. Wait,
L
12?
Yeah, because the L multiplied by okay, I'm sorry. L plus W into 2 equals 24. I'm sorry.
Yeah.
L plus W. L plus W equals 12. L plus W equals 12. Not L multiplied by W equals 12. L plus W equals 12. So because they're giving you the perimeter.
Yeah.
So then you just need to find out the maximum area, So they're just trying to take the value like this, L, W, and area. Consider like L, this is W, and this is area, right? So they're just trying to make a table. For an example, when the L is 6 and the width is also 6, the area becomes 36. When the L is equals 7 and the width is equals 5, it becomes 35. And when the length is equal to 8 and the area equals 4, it becomes 32. And when it becomes 9, 3, it becomes 27. This is the length, this is the width, and this is the area. You got it, right?
Yeah.
So the highest area would be covered 6 and 6.
Oh. Oh.
The highest area that can be covered, that is basically 6 by 6. 6 length equals 6 and the width equals 6.
Yeah.
This is basically, I have just written some
But I have a
run-down.
question.
Sorry. Yeah, sure.
Yeah, so the perimeter is 24, but how would you know when to maximize it? Like, what does it mean to maximize the area?
The maximizing the area means basically maximizing the area means you just need to the perimeter, because they're telling you the perimeter. I'm sorry for my bad handwriting. That they're just telling you the perimeter, the length of this side, the length of this side, the length of this side, and the length of this side. Sum of all of these sides are the perimeter, and they're just giving you the perimeter, and they're just telling you. For an example, the object can look like this. The object can look like this. The object can also look like this. Maybe they all have the same perimeter. This is basically the perimeter. This is basically the perimeter 24, right? P equals 24. Maybe this also has the perimeter P equals 24. This is also has the P equals 24. This is also has the P equals 24. Maybe, just consider it. P equals 24, P equals 24, P equals 24. Consider it like this. P equals 24. This is P equals 24. This is also P equals 24. But the area is not the same. The area is different. The area is different. So you just need to find such an object which for which the perimeter equals 24. The perimeter equals 24, and having this identical perimeter 24 unit, the area is needed to be the maximum. The area is needed to be maximum. The highest area that can be covered by a rectangle or a parallelogram, maybe a rectangle. Okay. So You just need to find that area. You just need to find the area, because maybe this also has the perimeter. This also has the perimeter 24, but maybe it doesn't have the maximum area. The maximum area. Maybe the same thing may be also happening for this. It has the perimeter for 24, but maybe it doesn't have the maximum area. Yeah, that's possible. And for this too, maybe it doesn't have the maximum area. But for these, maybe it has the maximum area. Maybe it has the maximum area.
Oh,
Maybe.
Okay, that makes sense.
So having same parameter, having same perimeter can having same parameter doesn't necessarily mean that you have the maximum amount of the area. You're gonna get the maximum area. That doesn't really make sense. Okay.
Yeah, I
Okay.
get it.
So yeah, you can solve this problem in calculus basically. If you understand, or if you try some calculus problems, maybe you would understand why this is happening, because basically this problem is a calculus problem, to be very honest. And that's why
Okay.
I was talking about the Coke can problem, because
Yeah.
they do some calculus to find out the maximum volume in order to optimize their cost, the production of their Coke can. Okay. Anyway, whatever it is, volume calculation. So you just need to find some volume for a box, and volume for a box we already know that it is length times width times height. What is the volume? What is the volume? What is the volume? With a length 2x inches, a width of 3x inches, and a height of 1 inches. I think you can do it. That is ax, that is 2x and 3x and
3x
y,
times y.
right?
Yeah.
6xy. 6x
Yeah.
squared y, right?
Oh yeah. Yeah.
6x squared y, okay? Okay, all right. So the volume of a cylinder is pi r squared h, pi r squared h. Do you understand the meaning of pi r squared h?
Sorry, pi what?
Do
Pi
you
r squared.
understand the meaning of pi r squared h?
Yeah.
Okay, for your kind information, I'm just telling you again, this is basically a
Radius.
cylinder. This is
Yeah.
basically a cylinder. So this is the radius, this is the radius, this is r, radius, r equals the radius, and h is the height, okay? H
Yeah.
is the height. H is the height of the cylinder. So if you want to calculate the volume, of any cylinder, then it would be pi r square h. And why this is happening? Because because for 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 any kind of 3D object, if it is basically a continuous type of shape means this is basically a cylinder, and it has a continuous type of shape with the respect to its with the respect of, its top surface. Okay, consider it as the top surface, and it has the same type of shape from its below, from the below to the top, right? Circular. This is a circle. This is a circle. It has infinite number of circles. Do you understand what I'm talking about?
Yes.
Okay.
I
Basically,
have a question. So to solve this one, can you use a calculator?
maybe you can use the calculator, or maybe not.
Yeah,
Actually, I
because
really don't.
how
That
would
is
you
depending
get
on
the
the
pi?
uh, test taker policy, and I will let
Yeah.
you know. What is basically they're trying to do. But I will let you know. I will inform you on that.
Okay.
Maybe I will inform you that as soon as possible. But maybe they will provide some calculator. Maybe because they're just doing some pi values here. Okay, because there is
Yeah,
some
that's
pi.
right.
We have some pi values here. So we have some continuous circle. New, mm, just use your imagination, okay? We have
Okay.
so many circles. For a circle, how do you find the area? Okay, how do you find the area?
Circle is radius.
Pi r
Something
square. The
yeah.
area is pi r square.
Yeah.
For any volume, for any kind of object, the volume is for any kind of object. The volume is area times height, right? Right.
Yeah. Yeah.
So for a cylinder, the area of these surface below down here at the below, at the top or at the below. Just consider this is basically a circle, right? A cylinder, a circle, and then multiply it with its height because the surface area here at this at this point and the surface area at this point are all the same. Even here, all the same. They are just consisted of infinite number of circles, right? If you just use your imagination, consider like this. For an example, consider like this. For an example, you have this circle, this circle, this circle, this circle, this circle, this circle. If you just gonna just put some circular cake one after another. Put some circular cake, okay? Circular cake. For an example, this is the cake. This is the cake, okay?
Mhm.
Put a cake just over on this. The similar look like cake, a similar circular cake over there. What will happen? The height will increase and the object will look like this, right?
Yeah.
So, so what I'm doing basically, I'm just trying to make you understand that is a cylinder is basically such kind of 3D object, such kind of 3D object in which we are just putting one circle one circle after another, within a given, infinite number of circles within a given, infinite number of circles. You don't need to understand this theory, but you can do the mathematics problems. But I'm just telling you, I'm just talking about the imagination basically, because if you understand this, how this is happening, then it will be more comfortable for you because the area and the height, the multiplication, the product of area and the product of area and height is the volume for a given cylinder. Okay.
Mhm.
I'm sorry for the noises. Is it disturbing you a lot?
No, I can't hear that much.
Okay, just give me a Okay, all right. So, for this, now focus on this problem. Focus on this problem. If you're interested to solve this problem, which is basically what is the volume of a cylinder with a height of 8 inches and a diameter of 4 inches. So this is a simple problem, right?
Mm-hmm.
This is a simple problem. That is pi r squared h. Pi r squared h. That is pi times r squared. The diameter is 4. The diameter is 4. So in order
Yeah.
to calculate the radius, you just need to divide it by
But
2.
yeah.
And that will become 2 square. And the height is 8, right?
Yeah. Yeah.
5 times 4 is 8. That is 2 pi. You got it?
Yeah.
Okay. Okay, all right. Volume of a sphere. We know the volume of a sphere is 4 by 3 pi r cube. 4 by 3 pi r cube. 4 by 3 pi r cube. Consider the volume of a sphere with a radius of x units, radius is x unit, radius equals x unit, how much greater will be the volume of a sphere with double the radius b? Consider the volume of a sphere with a radius of x units. Consider the volume of a sphere with a radius of x units. How much greater will the volume of a sphere? How much greater will the volume of a sphere with double the radius b? How much greater? So you just need to think about, for an example, consider two different spheres. That is V1, volume 1 for the sphere 1, that is 4 by 3 by R cube, R1 cube, R1 cube, that is 4 by 3 pi x cube, x cube, x cube. The R1 is the x1, R1 is the x, R1 is the x. And then V2, and then V2 is how much greater the volume of it, double the radius B, 4 by 3 pi R2 cube. That is 4 by 3 pi. What is the value of R2? The R2 is twice x, right? R2 is twice x.
Yeah.
Why? R2 equals to 2R1. And the value of R1 equals 2, and the value of R1 equals x, right? R1 equals x.
Yeah.
So put the value of R1, that is 2x. So R2 equals 2, R2 equals 2, and 2x, 2R, 2x cube, 4 by 3 by 8 times x cube. 32 by 3 x cube. This is V2. This is V2. This is V2. So V2 divided by V1. This is, you just need to do the calculation like this, 4 by 3 pi x cube and 4 by 3, that is, I'm sorry, 32 by 3, 32 by 3 pi x cube. X cube by x cube are cancelled. 4 by 3, 3 and 3 is cancelled. You got it, whatever I've done here.
Yes.
Simple argument. You just need to use your intuition. You just need to use some logic. The logic. You just need to understand the logic. Maybe they're just doing some in different way, but I'm just trying to make you understand how you should think. This is the way you should think, because it's not time consuming. At times when you are just trying again and again, when you are practicing again and again, then these things will become much easier. Then these things will be much easier. After a certain time, you won't be needed to solve problems like this way. You can just look at the problem and make the argument, make the condition, make the logic, and then you will be automatically able to solve the problem. I'm just trying to make you understand about the way of thinking. Maybe the way of thinking, right? The way of thinking. Okay, all right.
Yes.
Am I noisy here?
No, I can't hear. It's okay.
Okay, all right. So, are these things boring?
These are actually helping.
Are you feeling boring?
No, I'm okay.
Okay, all right. Maybe you just need to do some practice, and
Yeah.
I will try my best to provide some notes basically anyway. So, volume of a cone, we know the volume of a cone, that is 1 by 3 pi r squared 8. This is the volume for a cone, and the concept that I'm trying to make you understand, the concept of basically putting one peg after another, putting one peg over the other, putting one peg over the other. If you just put infinite number of circles over each other, then you would get a cylinder like this. And for the cone, the concept is a little bit different. Then you just need to continuously change the circle, the area of the circle. You just need to continuously change the radius of the circle. For example, uh, a cone is formed just like this way. Just like this way, you just need to put a circle like this, and then you just need to put a circle like a little bit less radius, left radius, a left radius, and infinite. I'm just writing some 5 circles here maybe, but to but to but to form a cone just like this way, you just need to put infinite number of circles continuously changing their radius, one after another. Then you would put a 3D object like cone. This is the way basically how a cone is being formed, right?
Yeah.
I'm just telling you, this is not important. These things are definitely not being asked in your SAT test, but I'm just telling you for your imagination, just to how to think about problems. Okay. So how many cones? Do you feel any kind of visible issues? Because my screen is, because I'm just putting the pages side by side. Okay. Are you comfortable with this?
Yeah, but I can see.
Do I need to solve? Do I need to use this like
It's up to
single
you,
page or
but
double page?
I'm fine with it.
Okay, I think double page.
Yeah, okay.
Okay, all right. Okay. How many cones of with radius 4 and height 6 will have the same total volume and the cylinder with the same radius and height? How many, how many cones with radius 4 and height 6 will have the same total volume as a cylinder with the same radius and height? You can just think about this problem and tell me how can I solve this problem. Just think about it.
Um,
Just give me some idea. That would be okay. I'm just talking about this problem.
okay.
How many cones of with radius 4 and height 6 will have the same volume? How many cones of with radius 4? How many cones? They're asking you the number of cones, basically. They're asking you the number of cones.
You can put like 2 different equations, one for a cone, one for a cylinder.
Yeah. You can use 2 different equations, and then what thing do I need to do?
And then like plug the 4 radius and the 6 heights in.
Yeah, that's it. Yeah, that's it. How many cones of with radius 4 and height 6 will have the same total volume? With the same, you just need to consider the volume of cone for uh, one equation, and then you just need to consider the volume for a cylinder in another equation, and then you just need to divide it. Okay, you just need to divide them. You just need to divide them with the volume of the cylinder or the cone, whatever it is. You just need to do the respective calculation. So this is how you're gonna solve this kind of problem. The way for a pyramid, the volume is one third of the length times the width times the height, which is basically 1/3 W L H, or whatever you write. You can just write it like 1/3 LWH, 1/3 of the length, width, and the height. So here is a problem that is considered a pyramid with with a volume of 20 cubic inches, if the width is cut in half and the height is doubled, what would be the volume of the resulting pyramid? You just need to do the simple plug-in values, and then you just need to make some equations, and then you just need to equate the equation, and then you just need to solve it, okay? Because that's the simplest way basically. So okay, now we have some practice problems. The practice problems are just like, what is the volume of a box with dimensions 3 inches and by 2 inches by 5 inches? 5 inches by 5 inches by 5 inches is meaning that we have the length, width, and the height. I think you can do it by your own, and we have some solutions here as well. What is the volume of a cone with a radius and height both of y centimeters? Just plugging in some equation, as simple as that. Problem number 3, what is the volume of a sphere with a diameter of 6 inches? Okay, this is also just a simple equation. Problem number 4. Problem number 4, how many pyramids with dimension 1 by 1 by 1 would fit in a box with dimensions 1 inch by 2 inches by 2 inches? You just need to compare. You just need to compare with two different pyramids. You just need to compare with two different pyramids, and you just need to make some equation. You can just make some algebraic equation, and then you just need to compare the both equation and evaluating them, because necessarily evaluation necessarily require two different algebraic equation whenever you are just comparing, because whenever you are just comparing, you just need two different equation, and you just need to divide them with one by another, just like this, because we are interested to compare how many pyramids with dimension 1 by 1 by 1. That is basically meaning the length, width, and the height. 1 by 1 by 1 means it means that we have the length 1, we have the width 1, we have the height 1 unit, would fit in a box with dimension 1 inch by 2 inch by 2 inches. So you just need to divide the volume of the pyramid with the volume of the box. That's it. That is how you solve the problem. If the height, problem number 5, if the height of a cylinder were tripled and its radius half, what would the volume of the new cylinder be as a multiple of the volume of the original? If the height of a cylinder were tripled and its radius half, what would the volume of the new cylinder as a multiple of the new volume of the original? You just also need to set some two equation. You just need to consider cylinder the volume 1 and the volume 2, and then you just need to compare. Write the equation for V1 and write the equation for V2, and then divide them V2 by V1. That is how you solve the problem. You got it, right?
Yes.
Okay, all right. Okay, all right. So we have some additional math problems like this. Fill in practice. That is, you should solve these problems, and if you face any problem, then you can just knock me. Problem number 1, problem number 2. You just need to go through with the additional problems. That is how you do it. Multiple choice practice. You can also solve the problems like this, and if you face any problem, then let me know. Okay, so we have some 10 problems. Okay, we have some 10 different problems, some 10 different problems, and some of them are multiple choice question, and some of them are some fill in the blanks problems. So you just need to solve these problems. So whatever we have just covered in this whole lecture today, that is I'm going to talk about from the very beginning. That is, we have covered the we have covered the basic of a perimeter and volume. Then we have come to know about that the set test taker will give us the formula, so we don't need to remember the formula. We definitely don't need to remember the formula. We know the area of the rectangle. This is the most simple example. We know the area of the triangle. That is also a very simple problem, and we also know the perimeter of polygons. We have we have done some problems. We have done some problems to find out the perimeter of polygons. We have done so many problems to find out the perimeter of a polygon. And to find out the perimeter of polygon, you just need to add all of the lengths of the sides of the polygon. You can also find the parallelogram area. You can also do some math problems on parallelogram area. I have told you that you just need to be careful about the height and the base, because you cannot just consider as to be this is the height. This is not the height. This is not the height. This is just the length of another side. This is the base and this is the height basically. So you just need to consider with that. Okay, so trapezoid area, we have done so many problems, some pretty amazing problems on trapezoid area, and then we have covered surface area. This is an amazing problem. We have covered the surface area issue, and then we have covered some pretty basic and fundamental problems, volume calculations, volume of a box, right rectangular prism. You can call this body as the right rectangular prism. Okay, this can call this body as the right rectangular prism. We have already dealt with volume of a cylinder. We know that is basically pi r square h, putting one circle after one another, putting one circle over the another, infinite number of circles of height h, infinite number of circles of height h, infinite number of circles, total height h. Okay, maybe you don't understand the theory, but that's not necessary. Volume of the sphere 4/3 pi r cube. We have done a problem because these problems are basically comparing equation 1 and equation 2. Just like equation 1, you have just done some things on equation 1, then you just need to divide with equation 2. That is how you do it. Or maybe just equation 2 or divide by equation 1. That is how you solve this type of comparison related problems. We have done volume on cone, volume of a cone, 1/3 pi r square h. And then how many cones? This was an amazing problem. How many cones with a radius 4 and height 6 will have the same total volume as a cylinder? Because this is just some division basically. Volume of a pyramid, 1/3 LWH. So this is also the same type of problem, because you just need to find out the area of the volume of a pyramid, and then we just need to find out the volume of the box. Okay, we just need to find out the volume of the box, and you just need to divide them with the another, and that is how you solve the problem. Okay, we have some practice problems. The practice problems also look like similar as the examples, and the solutions are already worked out. So you can go through the solution, and we have some set math questions practice still. So you are suggested to solve these problems just by taking 12 minutes. So solve all of these problems within 12 minutes. And then we have some multiple choice practice, and that is how this chapter is covered. This is how this chapter is covered, the area, parameter, and volume chapter. Okay, this is how the chapter is finished.
Mhm.